Our next speaker is Ziad Asghar. Ziad is the Senior Vice President of Product Management at Qualcomm. He has more than 25 years of experience in the wireless semiconductor industry, where he has held a broad set of leadership positions from R&D to product management. Today, Ziad will discuss unlocking innovation with RISC-V and Qualcomm. Please join me in welcoming Ziad to the stage.
All right. So I think one thing is very clear. We are at a great point where RISC-V is really gaining momentum. It is really getting to a point where we have multitude of products that are coming out that are all able to use many of the advantages that RISC-V brings to the front. Many of the speakers talked a lot from the perspective of the server side. I'm going to talk a lot more on the edge side of things. And if you take a look on this slide, I mean, just the size of the opportunity, when you look at what we have from a mobile perspective and from the side of automotive and industrial IoT, AR and VR devices, it's a massive opportunity. These are devices that actually touch the consumer, right? And if you went out there and asked somebody today, do you want RISC-V in an XR device? What do you think the response would be? They probably don't know. But that's perfectly fine. I think the key point that a consumer cares about, and we do a multitude of analysis and surveys on this, what they really care about is the ability to have a product that has better performance, to have a product that has better power consumption, a product that's very snappy, is able to do a good job. And honestly, those are all areas where RISC-V can really excel and differentiate itself. These are the areas where RISC-V can really show its value, because essentially what we can do with RISC-V is we can create custom solutions for each and every one of those applications, and we're actually able to get the right power in place. We're able to get the right performance, and we're able to get the right area. And by the way, that translates directly into cost. All of those factors are absolutely critical when we talk about consumer products like the ones that I'm talking about. So I'll start with kind of how we have gone about some of the progress that we have made on the RISC-V from a Qualcomm perspective. But I think the opportunity is just massive for RISC-V to really be able to show its value with what really matters from a consumer's perspective. If you look at the global footprint of these edge devices, it's truly unbelievable. At any given point in time out there for Qualcomm Snapdragon products, we have billions of devices out there, maybe a couple billion at any given point in time. And then every year we introduce a few 100 million more that comes into the ecosystem. So the opportunity in just a sheer scale, once we are able to actually bring RISC-V to these, is just massive. These devices, of course, extend into XR and PC and into IoT products. And we just launched our latest platforms, the Snapdragon 8 Gen 3, and also the Snapdragon X Elite for PC side. But we have the ability to be able to do even better with RISC-V. And I'll talk about where we are today, but what we can really do as an ecosystem. And I think this room really talks to the fact on really the breadth and the momentum, but really just the full scale of what RISC-V ecosystem looks like, and that's amazingly promising, I think, in my opinion. Where did we start? So our first product that actually had RISC-V microcontrollers in there was a Snapdragon 865 product. And I remember it very distinctly because this was in 2019. But as you guys know, from a silicon development cycle perspective, a product launch in 2019 means that we started to work on this around 2017 or something like that. So really what we were looking for was an embedded microcontroller that was actually able to meet the needs for a certain given block within our SoC. And we actually found RISC-V to be able to meet the requirements extremely well. So that's really where we started from, 2017. But I think we have come an amazingly long way since then. The momentum that we see today, you heard from many of the other colleagues and other speakers before me. So with that chip, we started with mobile. But just as Qualcomm has evolved, Qualcomm has gone from a company that was purely focused on handsets. We have gone to doing XR, which is AR and VR devices. If you pick today, if you pick up any device that does virtual reality and a device that matters, it's actually based on Snapdragon. If you look at automotive products, whether it's IVI or ADAS, we have an amazing amount of capability. So with that, by 2022, just like we showed last year, we had shipped 650 million devices with RISC-V. Well, that's an amazing number, right? Well, what has happened since then, today we are in excess of 1 billion devices that have RISC-V integrated microcontrollers in them. That's a massive number. It just talks to the fact that when you're able to bring these capabilities to the edge, just the sheer scale of these products really allows you to be able to scale, to really be able to show the value of RISC-V in a very, very massive fashion. Now, many of the speakers before me talked about this also, but I think the reason why RISC-V takes precedence in many of these applications is the fact that it is open source, is the fact that you can actually, if you have a core team, a team that can develop cores, you can actually go and create your own cores, but now you can customize it for exactly the need that you might have for a given product line. It is, of course, scalable. It's very modular. The part that I'm very, very focused on is the fact that it enables differentiation. It enables innovation. What you can do is you can bring in those custom instructions, or you can really formulate a CPU core or a microcontroller that meets exactly the needs and allows you to create a product which meets the need from a consumer's perspective. And that's what I said in the beginning. It has to be a product that's better in terms of the experience that it offers to the consumer. And RISC-V really has the ability to allow us to be able to do that. And each and every product line has different requirements. It has different takes. And if you can actually customize the solution for all of those different product lines, you essentially are able to add a lot more value to the consumer's experience, and that is key on the edge. Now, of course, if you look at the full value chain from the perspective of any product, whether it's a industrial IoT product or it's a PC product, you start with instruction set as the baseline. You are able to develop CPUs and other cores that are able to leverage that RISC-V ISA in this case. You're able to create SoCs, and then those go into, which is exactly the key next step that we need to get to, which is being able to go with support for full-up, high-level OS that's actually available. And that's where partners like Google come in. And you have seen that they are actually getting to a point where we are seeing a lot more support with AOSP and others, and I'm sure they will cover the details as well. But what we want is the ability to be able to take any high-level OS and be able to bring them into RISC-V products, right? That is going to be the key. We want to have the best-in-class instruction set. We want to have the best-in-class CPUs from a performance, power, area perspective. We want to have the best-in-class SoCs with the greatest camera quality, with the great AI technology, with the great graphics capability. That is what makes great products at the end of the day. And that's what we are targeting at Qualcomm, essentially. Now, from a software perspective, I think other speakers have talked about it too. We really want the software ecosystem to flourish, for it to develop more, and across all the different layers of the software. We want, of course, adoption of existing standards, but also best-in-class practices to be able to get to open source deliverables that allow a developer, whether it's a two-people team or it's a company that has hundreds of thousands of employees, it's able to actually use that capability in a very easy fashion with secure and reliable sort of open source software deliverables. You also want compiler enhancements that leverage the unique advantages of the RISC-V ISA. At the end of the day, RISC-V ISA has this unique opportunity that they are not burdened with all the legacy that other ISAs are burdened with. We have the ability to be able to innovate from that angle, and I think that sets a very amazing starting point. We need to be able to normalize the software security stack that's available to cover each and every product line. I'll talk a little bit about generative AI and how the security part becomes absolutely critical there as well. We need to focus on tools, languages, and libraries such that this is actually no different than some of the other speakers before me. I think Prahlad talked about this also. But we need to have an offering that is par or even better than what is available with other instruction sets. So this was a great momentous sort of announcement that we had. This was a couple of weeks ago where we talked about our engagement with Google. What we are going to be doing is to be creating a product for wearables, which is a smart watch that actually uses RISC-V as the application processor. This is an engagement with Google. This is a product that will be launched globally. But look at what this means. What it means now is you have the full OS, full Android OS running on a device like a smartwatch. This is going to be a chip that basically has a 5G, best-in-class 5G modem sitting next to it. It's going to have an audio accelerator, a video accelerator. It's going to have an Adreno graphics core. It's going to have AI capability, the best-in-class DDR capability. It is a platform that pretty much exercises everything that is available on any edge product today. That's what we have been driving towards. So I'm very, very excited with this engagement that we have with Google. We'll be able to get all of that to the front, starting with this wearable product. What we also have to think about is where do we go from there. But first, I think other speakers, including Callista, talked about what we have been able to do to solve and also really accelerate some of the key things that we need from a RISC-V perspective. And that is the RISE engagement, which is the RISC-V software ecosystem. Companies like Qualcomm, Google, Samsung, and others, basically we're working together to create these open source software deliverables that people can take and create end products. And these products that are amazing with the least amount of friction to be able to bring these products to the market. So very excited about what the team has been able to do on being able to engage and start these kinds of engagement on the software side. There is a similar analog on the hardware side as well. This is where we need to be able to have hardware IPs that go around the CPU core. These are things like the MMUs or the interrupt controllers or the security solutions, but all of the solutions that make up the complete SoC. And we've been working with many partners on that. We've been working with many of you in the room. But what we also did was to create the RISC-V scaler, which is really a consortium working with Bosch, Infineon, Nordic, NXP, and others, to be able to accelerate and start to drive towards a roadmap for these IPs and then be able to offer to the whole RISC-V ecosystem. So really, we're very focused on making sure that RISC-V continues to grow, develop, and flourish. It's a great point today, but there are areas where you can even do further and we can do better, and those are the areas that we really want to focus on. So the way we develop technologies at Qualcomm is what we call our one technology roadmap. What it means is that basically we take, for example, a camera IP, or we take a graphics IP, and we essentially start to work with it. We create that core technology, and then we are actually able to take that into a different product line based on the needs. So we might develop, for example, a camera. When you develop a camera for a smartphone, you typically want that image to look very good. You want basically the face to look nice and clear. But the camera for an automotive is very different. What you want in that case is basically being able to look into a single frame. Half of that frame might be lit with light, and half of that will be completely in the dark. But you should be able to discern everything that's there. That's exactly what we want to do with the RISC-V CPUs as well. We may be starting with the wearable or the smartwatch, but what we need to do is to be able to scale these very easily into all of these different areas that at least Qualcomm operates in. So if we look through and think through some of these product lines, if we think through, for example, the smartwatch that we started with, right? Smartwatch, one of the main things that is very important, or a driver over there, is the lowest power consumption. You want to be able to have that smartwatch last the longest with an extremely small battery in a very constrained space, typically like a 300 milliamp hour battery or smaller than that. So really, one of the key things over there is to be able to be most power efficient. Well, like I said, RISC-V does not have a lot of the encumbrances and the baggage of a long period of time, and this is again our opportunity to leverage that advantage into being able to create a smartwatch, to be able to show an experience that's far better than what we are able to do in the past. In the same way, if you look at automotive, there are requirements like lockstep. There are requirements like functional safety. You require a lot more threads, many a times very, very symmetric threads across the board. If you look at the PC side, we just launched Snapdragon X Elite. It has 12 large cores in it. The form factor is large. It's more forgiving from a power perspective. You go to a smartphone, it's an 8-core device. It has 3 different types of cores that come together. That's exactly what RISC-V needs to be able to do. Performant cores from the lowest end at the lowest power to the highest end, and we are seeing that ecosystem develop in a very, very strong fashion, which is truly amazing. At the same time, what you want is to have the ability to be able to mix and match those cores. Take some of the smaller cores, take some of the larger cores, be able to create that full construct where, for example, a smartphone, you want that peak performance when you're doing the gaming experience or you're launching an application. But then you want to be able to get to the lowest power when the phone is in sleep mode, for example, such that you can conserve power as much as is possible. That's the flexibility. That's kind of the scale and the breadth of what we need with RISC-V as well. And then what we can do is, starting with that smartwatch example, we can actually take that to a smartphone. We can take that to an augmented reality device, to a virtual reality device, to a security camera-like product, to a PC, or to an automotive. It's all up to us, really, as to what we are able to do. And that's why we need to grow and drive the RISC-V instruction set to be able to deliver those values that we are talking about. But the opportunity is huge. Again, a RISC-V-based product needs to win on its merits. This is what I tell my team. When we go to RISC-V in these products, such as smartwatches, It needs to have better power. It needs to have better performance. It needs to have better area, right? Those are the metrics that matter. It needs to offer a better experience to the consumer. Now, what do we need for RISC-V to be successful, right? I think there is a lot of work that this group has been doing on the instruction set side. Of course, we want aligned instructions, and I think the previous speaker talked about this too, but we want opcode space to be able to add those custom instructions in the future. We want definition of vector that's happened to a great extent. We want matrix to be added in there, right? As we bring in workloads like AI. AI lends itself extremely well to matrix processing, right? We need to have those things come into the ISA. But most importantly, we want the execution and the improvement in ISA to happen at a faster pace. I think that's how we win. I think some of the work that was done on vector was great. We probably could have done it faster. I think those are the kind of things that we want to really stress upon. We want higher performance CPUs, and I think like Balaji presented in the morning, that's really coming up, which is really great. We want multi-core cache coherent solutions. And then based on that, we can create these amazing chipsets like the smartwatch that I talked about with all that technology crammed into it at the best power consumption possible. I want to talk a little bit about this thing that you guys might have heard about a little bit called generative AI. It's a huge trend, but it's also an amazing opportunity in my mind for RISC-V. Because RISC-V can do a lot of these workloads perhaps better. What should we be thinking about how to make RISC-V as the key driver for generative AI? I want to start this with an experience that we showed at our Snapdragon Summit, but we'll just give you an idea of what we're planning to do purely on the device. It actually has audio, so I'm not sure if they can enable it. In the morning, it was working.
In New York, departing on December 1st.
Here is the travel plan for your destination.
Can you add 2 adults to that plan?
Here is the modified plan.
Can you change the departure date to December 15th?
Here is the modified plan.
Okay, submit that.
Okay, I will send your plan to the travel website. Here are your booking options.
But with this experience, apart from the information that was coming from the Skyscanner plugin, was all happening purely on the device. It's an amazing amount of capability that we are able to do with the edge devices today. With the advances in the large language models and the capabilities that are being packed into it, we have an amazing technology and an amazing capability to be able to do a lot of these on smartphones, to be able to do them in XR devices, to be able to do it in PCs, which, by the way, extends you huge advantages of privacy and immediacy, right? Now you no longer need to worry about that query that you put in there, that it has gone onto a server and it's sitting somewhere. You take a PDF document and you send it up there for summarization. And now that proprietary document might be out there sitting on the server for quite a long period of time. We can do all of this on the device. I mean, just to give you an example for this particular use case, the voice of the person was actually going through automatic speech recognition. That's a 240 million parameter neural network model that's running partially on the sensing hub over there, which is our very low power AI subsystem. Then it goes into a large language model, which does the text-to-text, which is, in this case, Llama 2. That's a 7 billion parameter neural network model. That produces the text output, which goes into a text-to-speech, which is actually running on the CPU in this particular case. And then it goes to the cloud to be able to get the Skyscanner data. But what it tells you is that essentially, for AI to work amazingly well on the edge, you want all these pieces to come together. You want the CPU to do what it does best. You want the GPU to be able to do AI processing when it can do a good job. For the NPU to come in when that can do the best job of doing a particular application. So for example, the text-to-text is running on the NPU. But like I said, the TTS, or text-to-speech, was actually running on the CPU. This is a huge opportunity for RISC-V. This is where the generative AI revolution, RISC-V can step in to be able to offer these experiences in a far better way. Like I said, some of the things which we have talked about, like vector and matrix, is one of the methods that we can use to be able to do a much better job of it. But I think this group over here, we need to innovate, we need to make sure that the instruction set has those advantages coming through for all of us to be able to leverage what generative AI is bringing to the front. It is a huge revolution, and by the way, this is just getting started. What I showed you was text-to-speech. We have the ability to be able to do things like text-to-image in less than half a second on the device. We have the ability to be able to do pretty much X to X in the future, which means multimodality models are coming in. And CPU does a great job, especially if it's, for example, a spotty use case, or if it's a use case that has very good or very strong latency requirements. We need to make sure that RISC-V is able to leverage all of those advantages in a strong manner. In the end, I want to talk about call to action. I think I've kind of hit on all of these points, but just to summarize again, I think we need to make sure that RISC-V ISA definition is moving faster. It's getting to adding these things, like we talked about matrix. We want to make sure that that gets done fairly quickly, and I think we in this room need to come together to really be able to make that happen. We want to enable a very easy path for those who are using other ISAs to be able to bring their investments, to be able to bring all the work that they have done from those to RISC-V. The least amount of friction to be able to do that. You, of course, want to define the most competitive ISA to be able to operate for all the different OSs that we talked about, whether Android, whether it's Google Wear, whether it's QNX, all the different OSs that we have out there. We want to allow the RISC-V partners to really innovate, to be able to bring their unique differentiation. But at the same time, I think it's absolutely critical for us to bring in a thorough certification regime to make sure there is interoperability and we don't get into the trap of fragmentation. I think if we do these things, I think RISC-V is looking amazing. And I think kudos to the whole group over here for what the team and what the ecosystem has accomplished in a short period of time. I think I look forward to how this continues to evolve, how we move from embedded devices into applications. And we at Qualcomm are super excited about how to take it forward. Thank you.